Hello everyone, my name is Naiya Chapman-Weems and I'm a senior. Today I'm going to be talking about my involvement in the NASA Suits Design Challenge and the security portion of the project. The NASA Suits Design Challenge challenges students to create an augmented reality spacesuit display. Since NASA doesn't have the resources or time to explore every single technology, so they use their platform to reach out to students at universities across the nation to create a solution that will help astronauts on their lunar missions, because this challenge targets the main aspects of the Artemis mission, which aims to land the next man and the first woman on the moon by 2024. As you can see in this photo, these are all of the teams who have been selected to participate. And this year we didn't get the chance to actually go to the Johnson Space Center to receive feedback on our solution and attend test week due to COVID. So we still decided to continue on and work on the project. So last year we were also accepted and our team was called the Programmers, but this year our team is called the Astro Bees. So as you can see, this is our official logo, and everyone who is participating this year is also listed along with their role in the project. And at the very top, you can see that Dr. Vincenti is our team advisor. So my role in the project pertains to the security aspect, and this is indirectly related to the project since most of the work involves creating an application and software for the augmented reality, but security is also important because we have to make sure that all of our systems are running properly and efficiently. So I chose to focus on this because I have an interest in cybersecurity and information security. And as you can see in this picture, this is a Raspberry Pi, which is a small computer, and it's about the size of a credit card. So the following things I've been working on: performance tests, securing the Raspberry Pi, disaster recovery planning, and failure flow charts and quality assurance. In order to conduct temperature testing, I created a Python script in the Python programming language that gave the temperature of the CPU at a given time. And since systems can't function at high temperatures, the temperature test is important to know when the system is nearing a high temperature. In order to conduct CPU and I/O disk benchmark testing, I utilized a bash script that gave the speeds of the CPU and I/O disks. And this is important in case the Raspberry Pi has to run on a portable battery. We need to know how much of an impact heavy loads have on power usage. All of these tests are relevant to security because any disruptions can cause vulnerabilities in the system, which we don't want. In order to create failure flowcharts, I used a website called draw.io, and I used this to create a diagram that mapped out the steps to take when something does go wrong, such as node failure or one of the nodes dies, something of that nature. This gives a visual of what to do when that particular scenario happens. In order to develop a disaster recovery plan for the project, I did research using scholarly articles since I chose this topic for my capstone paper, and I was interested in learning more about what goes into developing a disaster recovery plan. For quality assurance, I collaborated with software developers who created the main code for our augmented reality, and just so they don't get too focused on making sure that something works and that's it, we have to make sure that our code is able to handle any errors or exceptions as they arise. This graph shows the output of a sample temperature test. The temperature in Celsius is on the y-axis, and on the x-axis is the minute. So this test was ran for 8 consecutive minutes, and as you can see, the temperature seemed to go down as time went on. So the startup is processor intensive, so there are lots of tasks that the CPU is running, and then as time goes on, they idle, so there isn't much activity after that. By the end of the semester, I will also do this for the CPU and I/O benchmark tests. One of the major successes of this project was learning without prior experience. I did not have any experience working with any of the technologies that I mentioned previously, so it was pretty amazing to me that I was able to catch on pretty fast and come up with solutions for problems that I had. And also, this goes hand in hand with what I just said, successfully writing code and scripts that function properly. I was surprised that I was able to do simple Google searches and YouTube videos to help me figure out what it is I needed to do. And of course, due to the pandemic, I was limited in my resources, so that was very helpful. And one of the main challenges that I had was getting all of this output to save to a file which I could convert into graphs to easier see our data, which is currently a work in progress as of this week, which is April 27th. So I'll be continuing to work on that. It was also challenging being thrown into the deep end and not knowing exactly how to overcome some of the problems that I face, but I am really satisfied with my growth throughout the semester. So our next steps in the project are to present exit pitches to NASA engineers in June 2020, which will be held virtually through Microsoft Teams or Zoom, and we will be persuading them to incorporate our solution into future missions. And some of us use this for our capstone projects and presentations. And we also had to do a capstone paper, so this project inspired our topics for the paper. And we'll also be preparing to participate in next year's challenge, gathering people for next year and improving our solution. To conclude, I want to say that this has been an amazing experience and I learned so much. And I had the opportunity to connect with people at NASA, people from other schools. Even though we didn't have the opportunity to go to the Johnson Space Center and see everyone in person, it was still really nice hearing from everyone throughout the virtual meetings and everything else. Also, I got a chance to finally learn things that I had never learned before, even in the classroom. So this will be helpful for me in my career. And this is not only just a school project, this is a real life solution that can be used for astronauts on their future missions. So it doesn't really get any more real life than that. And also, I just want to point out this picture of myself and a few other teammates. We got the opportunity to meet Mae Jemison at the Enoch Pratt Free Library, not too far from UB, the Central Library, at a Black History Month event, and I never thought in a million years that I would be here. So I'm really, really grateful for all of the opportunities that this project has given me. Thank you so much for listening, and I'm looking forward to everyone's questions and feedback.